Hey everyone, welcome to another video of hok'stutoring. I hope you're having a great day. Today we'll be going through another, I suppose, topic video of product rules and quotient rules. So again, similar to what we did in the last video on chain rule, this is going to be an explanation of what exactly is product and quotient rule, how to apply these two rules, when to use these two rules, and then, the shortcut to using the product and the quotient rules. So stick along till the end if you want a full explanation of how to use these rules. Without further ado, I might as well get into the video. So the first part of this video, we will talk about product rule. Okay, so product rule is very simple. In chain rule, you have an equation where the general form of when to apply it is when you have a composite function, right? So you have g of x inside f of x. With product rule, as the name implies, product, that means multiply. So instead of a composite function of, where you have g inside of f, you just have f, which is one function, multiplied by another function, okay? So if you see an equation in this form and they ask you to derive the function or the equation, then you can apply product rule. And the formula is very simple. dy dx equals to f dash of x multiplied by g of x. So you only derive one function, and then you multiply it by the original of the other one, and then you add it to the original function of the first one, multiply by the derivative, okay? So they take turns getting derived, but they are never derived at the same time, okay? So that's the product rule. And this equation is very simple, okay? This formula is great. This is the only shortcut that you need to know. Other forms, other varieties is you might see y equals to u multiplied by v, and then dy dx would be u dash times v plus v dash times u. So you might see this in the formula sheet, so don't be confused. It's just a different variation of using this, and I would recommend you just stick to one, just know what it is inside your head, so that you can apply it instantly when you encounter these type of questions. So product rule, very simple. We will go into one example on how to use product rule, and then I'll jump into quotient rule next. So product rule, as an example, let's say we have y equals to x squared plus 2x plus 1 multiplied by e to the power of 2x. Let's just say that as an example, right? And in this case, if I want to derive it, so dy dx, okay, so we want to find the derivative of our equation right here. It's very simple. You need to determine what is, what are the two functions, what's f, what's g. So that's up to you. You can make f the first one, g the second one, or f the second one, g the first one. It doesn't matter with product rule. You can do whichever order first, because in addition, the order does not matter, okay? So let's say this is our first one, and e, the exponential, is our second equation. We want to derive them at separate times, I suppose. So let's derive the quadratic first. So x squared plus 2x plus 1, derivative, and I like to put things in bracket, okay? You get 2x plus 2, and because if you don't put them in bracket, let's say you only had 2x plus 2, and this is very common basic maths, and I hope I hope that out of this you can learn not to make this very rookie mistake, is put a bracket, or else you'll end up with something like this, and then that's not good, okay? Because then what the examiner or teacher is going to see is 2x plus 2 multiplied by the exponential instead of 2x plus 2 in a bracket multiplied by the exponential, okay? So you have to be very careful with that. And yes, so the exponential, we leave them the same. Remember, it's f dash, you only derive the first one, and then the second function, you leave them there, just as is, don't do anything to it. And then the second term of the product rule is fx, which is the original one, so of the first term, of first equation. So you leave that there, and then now you derive the second expression. So in this case, the exponential. So when I'm deriving exponential, I derive the top. If I derive 2x, I get 2, and I multiply by, again, just the exponential as it is. Don't touch it, don't do anything. So then now you have the derivative of the second function, g dash x, okay? All you need to do now is essentially just simplify it. It's very simple. You have, let's look at the first term, you look at the second term. What is common? Well, I see there's an e2x here, so you can take that out, e2x, and then you're left with 2x plus 2 as part of the first one, plus 2 multiplied by the bracket x squared 2x plus 1, and you can see an opportunity to expand this bracket and then simplify it even further. And teachers love that. Like when they basically see you simplify things right down to its simplest, most basic form, then they're gonna appreciate your work, and you're more likely, I suppose, you're it's more certain that you get the full marks, because some teachers can be very strict and they can see that you didn't really simplify it. So just be careful. I like to simplify things just to make it certain that I'll get all the full marks. So make sure you do that as well. Expand the bracket. Just gonna do it right here, and then just add them up. Okay, so begin with the x squared. That doesn't do anything. The 2x and the 4x becomes 6x, and the 2 and the 2 becomes 4. You can then even take the 2 out of this, and you can get 2e to the power 2x x squared plus 3x plus 2. And yes, I know, guys, you can probably even factorize this even further. So yeah, it's very, if you want to go down to that level, then yes, you can, and I might as well do it here. X plus 2, x plus 1, bingo, there we go. That's how you, I suppose, use the product rule to differentiate a function multiplied by another function. Very simple. The shortcut is pretty much just that. You don't need to let u equals any more of these things. Just go straight into the differentiation technique. Right, so that is product rule, guys. Hope you understand that part. We'll move on to quotient rule as the next form. So quotient rule is very similar to product rule. The form that you apply quotient rule. Quotient means essentially like division. So you have y equals f of x divided by g of x. So in product rule, you have one function multiplied by another. In quotient rule, you have one function divided by another. And the derivative of this and the order matters. So it's very important that you understand that the order matters, because if you apply this formula and with disregard to the order, you're going to mix it up and you're going to get it wrong. So just pay attention to this part. G of x, so whatever function is at the bottom, you have to square that function and then leave it at the bottom. Okay, and then on the numerator, you derive the function at the top, so f of x, you get f dash x, multiply by the original function in the denominator, and then you subtract. So the order matters, because 1 minus 2 is not the same as 2 minus 1. Okay, these are different. You get different results. So make sure you derive in the first term, you derive the top function, and then you multiply by the original minus the derivative of the denominator multiplied by the original function at the top. Okay, so the numerator. So the order matters. It's very important that you know which one is f, which one is g. Okay, so that is quotient rule. So f dash x times gx minus g dash x times fx divided by the numerator, the denominator, gx fully squared. Okay, so I'm gonna stick to the same example that we used last time, but in this case, it's going to be one function divided by the other instead. So let's say we have x squared plus 2x plus 1 divided by e to the power 2x. Okay, so in this case, what do? Apply the formula dy dx, and I always like to start from the bottom first. That's the easiest one to do. E to the power 2x, well, e to the power 2x, we just make that fully squared. Do not derive it, leave it as its original, and then just square that. And then now you go work towards the numerator. So with the numerator, you get f dash x multiplied by gx. F dash is the derivative of the top function, and we did that before. Make sure you put it in bracket, make it look very nice. You get 2x plus 2 multiplied by the denominator, so e to the power 2x. Leave it, don't derive it. And then subtract, you have the denominator derived, so e to the power 2x, when you derive that, we know we get 2e to the power 2x. And then you multiply by the numerator underived, if that's a word. So the original. So x squared plus 2x plus 1, leave it as it is. Bingo, there we go. And then now it's all about simplifying. You've done the hard yards, you've done the derivative, you've used the formulas correctly. Now it's all about simplifying. So again, this is going to be a pretty big equation. Let's start with the bottom. E to the power 2x squared. Using the exponential law, we know that if I have x to the power of a and then it's to the power of b, you get x to the power of a times b. So you just multiply the two powers essentially. So in this case, e to the power of 2x multiplied by 2, and you get e to the power of 4x. Very simple, leave it there. And then on the second half, you can probably take the 2 out of this one. So 2x plus 1 multiplied by e to the power of 2x minus, and again, leave that there. Can't really do much with this one. Oh, you can square this if you want. So that's one way of doing it, because that's a perfect square. But yeah, up to you. There's so many different ways of doing it. We can then factorize out e to the power of 2x, and you end up with x plus 1 for the first term. And then on the second term, you end up with, well, there's a minus, okay? Make sure, don't forget the minus. A lot of students make this mistake. They forget the minus and they forget the bracket and they mess up the symbols. Minus x squared plus 2x plus 1. There we go. And then e to the power of 4x. And as we keep going through the equation, you get x plus 1 minus x squared minus 2x minus 1 divided by e to the power of 4x. And then you're almost done, guys. You get e to the power of 2x. Minus x squared stands by itself, and then you get plus x minus 2x, you get minus x. The 1 and the negative 1 cancels each other out, and you get e to the power of 4x, and then we're almost there. And excuse my line, I can't draw a straight line today. You can factorize out the negative x out of this, so you get negative 2x e to the power of 2x. This is just my preference of writing this. I like to have a number and then the x and then an exponential afterwards. And what you're left with if you take out negative x, okay, because we took out negative x, is you have x and then plus 1. Okay, guys, e to the power of 4x on your denominator. And guys, this is your derivative of the function that we had originally using quotient rule. Okay, I hope that you found this example and the initial tutorial on how to apply product and quotient rule in this video useful. And I really hope that this helps you in your exam, in your SAC, in speeding up the process of how to apply in applying these rules. So guys, that's pretty much it for this video. I hope you enjoy, and if you did, please leave a like and subscribe to the hok'stutoring YouTube channel. I would greatly appreciate that. But otherwise, thank you for watching, and I'll see you next time.